Sustainability seminar. My name is Laura Barnes. I am the Sustainability Information Curator at ISTC and Executive Director of the Great Lakes Regional Pollution Prevention Roundtable, and I'm going to be your moderator today. Today is the first in our fall 2018 Sustainability Seminar Series. The listing of our other upcoming seminars is available on the website. The next one is going to be on September 20th, when we will welcome John Steyer, who's a sustainability mentor for the Brewers Association. He'll be discussing sustainability in the craft brewery industry. Please plan to join us for that and for our other seminars throughout the semester. In case you can't attend in person, all of the seminars are shown live via GoToWebinar and are also recorded and archived on our website in case you happen to be busy that particular day. It usually takes about a week for the video to be posted after the presentation date. I'd like to remind everyone in the room with us to please silence your cell phones. We will hold all questions for the speakers until the end of the presentation. I'll come around with a microphone at that time for questions from people here in the room. For those of you viewing online, you may also type your questions in at any time and we'll answer those at the end. With that, we will begin today's seminar. We're pleased today to have two of our own from ISTC, Nancy Holm and Jennifer Martin, presenting a talk on looking ahead at solar panel recycling in Illinois. Nancy is the Assistant Director for Sponsored Research, Public Engagement, and Communications at ISTC. She joined the staff in August 2006. She oversees a sponsored research program which funds research and education projects through the State of Illinois Hazardous Waste Research Fund. In addition, Nancy is involved with several research studies on the fate and transport of chemical contaminants and microplastics in the environment. She also coordinates ISTC's new solar panel recycling initiative. Nancy received her BA degree in biology and chemistry from Luther College in Iowa and her master's degree in limnology and oceanography from the University of Wisconsin-Madison. Our other speaker today will be Jennifer Martin. Jennifer joined ISTC in the spring of 2018 as an environmental program development specialist. She works on tracking emerging issues and research needs related to water, public health, and the environment. She's assisting with ISTC's new solar panel recycling initiative. Her prior professional career includes a wide range of experience developing and evaluating community college programs relating to energy and conservation. Jennifer's work was essential to the development and implementation of solar training workforce strategies for technical training programs, solar employers, and communities throughout the state. Her work helped build a more robust solar energy workforce in the Midwest. Jennifer received her BFA degree from Ball State University, her AAS degree in sustainable energy from Ivy Tech of Indiana, and is nearing completion of her master's degree in sustainable management from the University of Wisconsin-Green Bay. Please welcome Nancy and Jennifer.
Thank you very much, Laura. I'm going to be speaking today in the first section of our talk, and then Jennifer will take over later for the last portions. So as Laura mentioned, both Jennifer and I are from the Illinois Sustainable Technology Center here. For those of you who may not know, we're part of the Prairie Research Institute here at the University of Illinois, and that's made up of 5 different divisions. We have over 900 staff members in the institute. It's one of the largest ones on campus. There's the State Archaeological Survey, Geological Survey, the Natural History Survey, Water Survey, and then us here at ISTC. ISTC's mission is to encourage and assist citizens and businesses and government agencies to prevent pollution, conserve natural resources, and reduce waste to protect human health and the environment of Illinois and beyond. To that end, ISTC in 2017 began its solar panel recycling initiative because we saw a need to address this issue of solar panel recycling, and it fits well within our mission here. So here's an outline for today's presentation. I'm first going to be discussing why are we interested in solar panel recycling, and then some of the most common recycling processes. Then Jennifer will take over, and she'll talk about guidelines for solar panel disposal, the status of solar panel recycling in the U.S., and then the outlook in Illinois and our next steps for solar recycling. So, to the first question, why are we interested in solar panel recycling? As many of you are aware, solar power is now the fastest growing energy source. There's an estimated 500,000 solar panels that are installed globally every day, and that was in 2015, so that number has increased now 3 years later. In the US, there were approximately 175 million solar panels installed as of 2018. And according to the Solar Energy Industries Association, SEIA, the total installed in the US is expected to double in the next 5 years. Globally, the installed solar panel capacity has reached 222 gigawatts at the end of 2015. And as you can see, it's just going to be rising exponentially over the next 20, 30 years to when they predict there'll be 4,500 gigawatts installed by 2050. To show some of the countries that have some of the larger installed capacity right now, China is the main one at this point. There we go. The leader right now, this was in 2015. And then Germany, Japan, US was fourth at that time, and then various European countries, and then India and Australia. In the US now, they have nearly 56 gigawatts of power installed, and that's equivalent to the capacity of generating capacity of 50 commercial nuclear power reactors. Illinois currently ranks 34th in the nation with 87 megawatts installed, but the growth potential and projections here are for another 1,400 megawatts to be installed in Illinois in the next 5 years. And Jennifer's going to be discussing some of the reasons why there'll be that large increase in the numbers. So as I mentioned, by 2050, we're going to have increasing amounts of solar installed throughout the world. And at that time, China will still be have the main solar capacity. India and the US will then be second, and then Germany, Japan, and then Germany will follow in the top 5. And so as we see this large increase in solar power capacity and the number of solar panels being installed globally and in the US and in Illinois, this will lead to a large volume of decommissioned and sometimes damaged solar panels. And we have to think about what we're going to be doing with those. There's predictions as of the end of 2016, it was said that there were about 43,000 to 250,000 metric tons of global solar waste. And that's about 0.1% to 0.5% of the cumulative mass of all installed panels, which was about 4 million metric tons at that time. So right now, we don't have a lot of the panels coming offline because they're still working with enough efficiency to stay installed. But we do have some early loss life category, which is about 80% of what's being recycled right now. And early loss is due to factors such as in transit or installation, or to harsh weather conditions such as hail, tornadoes, hurricanes can damage the panels. And then also there's some PV materials that need to be recycled from fallout during the manufacturing process. So for some numbers, we see about 0.05% of the installed panels fail annually, about 0.05% fail even before leaving the manufacturer each year, and then about 2% of the panels are broken in production. But then, as I was mentioning, there's not as many panels coming offline right now because the design life of solar panels is about 25 to 35 years. But we're going to be seeing a huge surge in solar panel disposal in the 2020s and 2030s because many of the panels started to become installed in the 1990s, 2000s. And so we will see a large increase of the need for recycling in the next 10 to 20 years. And by 2050, globally, there's going to be 60 to 78 million metric tons of solar panels solar panel waste. So with these extreme numbers of waste from solar panels that are just going to be increasing over the next 10, 20, 30 years, we see this as a growing issue, and that's why we started our initiative to begin examining this imminent problem right now. And as an article recently in April in Solar Power World said, it's time to plan for solar panel recycling in the United States, and we feel also for, of course, in Illinois. So this is a looming waste management issue, and many countries, however, including the US, really don't have a strong infrastructure in place to be able to handle this volume that will be coming. And we believe that the panels should be properly recycled, because otherwise we could have some heavy metals that are in the panels, such as cadmium or lead, or other compounds that could leach into the environment. There's valuable mineral or resources in the panels, such as silver, that we don't want to end up in landfills. And then there's some finite resources that are slowly being depleted that will be lost if we put them into landfills, such as rare earth elements, such as gallium or indium. So that discusses why we have an interest in solar panel recycling and the looming waste problem that we see. And now I'm going to discuss briefly some background on what are some of the common recycling processes. So as you can imagine, with the panels being made of different types of materials, this could be kind of a complex task to recycle them. There's different metals I had mentioned. There's an aluminum frame, the silicon solar cells, and then synthetic material that encapsulates the silicon. And these all have to be separated to properly recycle them. And then if there's some undamaged solar cells that just have lost their efficiencies, we can often recover those and reuse those in other products. So it's important to think about the type of technology and the composition of the solar panels when we're discussing recycling methods. So there's two main solar panel technologies right now that dominate the market. There's the crystalline silicon, which is the oldest PV technology, and that has a market share of about 92% of the panels. So that can be either a multicrystalline or a monocrystalline silicon panels in that department. And then we have two thin film PV panel technologies that make up about 7% of the market. And we have a 2% for the SIGS panels and about 5% for the cadmium telluride. This table shows some of those numbers again, the percentages, and as I mentioned, this is dominated by the silicon-based one. But what will need to be considered as we look at recycling and the technology used to recycle and the materials we will get out of the recycling, we can see there's going to be some changes in the types of solar panels we'll have over the next 20 years. And so predictions are that by 2020, this will decrease to about 73% of the market share and then to 44%. However, if you look at this line, crystalline silicon will still be a dominant player in the market, but there'll be some more advanced types of the crystalline silicon panels. So that's going to go up to about 25%. So together, these still will be about 75 or 70 to 75% of the market share. The ones that will be changing some, the thin film, this SIGS, which is copper, indium, gallium diselenide, will stay about this, will grow a little bit, but stay at about 6% level. Cadmium telluride panels will stay about this same at about 5%. But we do see growth in particularly this, the SIGS alternatives, some with heavy metals and some advanced types, that will grow from about a 0.6% market share to about 9%. So with these changes in the technologies, of course, the recyclers will have to be aware of that and maybe change some of their systems that they use for the recycling. Right now, I'll just review a little bit about the composition of some of the panels so you can see the different components. And we have for our crystalline silicon panels, about 76% of that is glass, about 10% is polymer, 5% is silicon, and then there's some 1% copper and about 0.1% of several metals, the silver, tin, and lead. And there's been estimated that with some new technologies, there might even be an increase in the amount of glass and a decrease in the amount of aluminum in those. Then for the thin film technologies, the SIGS thin film panels are about 88% glass and about 75% aluminum and 4% polymers with small amounts of some of these metals. And then the cadmium telluride thin film is about 97% glass and 3% polymer, and then different metals in that composition. So many people may not be aware that actually right now we can even recycle most of the components of the solar panel. We can take out the glass, the aluminum, copper, plastic, and some of the metals. For silicon-based ones, there's a 96% recovery rate, and the other 4% is usually used in the waste-to-energy technology, energy recovery. And then for the non-silicon-based ones, that can have a recovery rate of the materials up to 97%. The Energy Power Research Institute, EPRI, has found that for most of the solar panel recycling going on now in Europe, it's being done by glass recyclers because they're set up to recycle the glass component. And then they might use some other techniques to separate the metals and do some recovery of those materials, or have another company help them with the recovery of the metals. However, the European Union is just funding recently, they announced a new pilot plant that they'll be having to do strictly solar panel recycling. And that's going to be able to recycle about 50,000 crystalline silicon-based modules each year. So you can see they are getting ready for this big surge in solar panels that we come, offline. As I had mentioned, and this just shows with a study of 5 of the current European recycling plants, that for recycling of the solar panels, the main component, they get about 60 to 70% of the glass is in the output. The red is the non-ferrous metals, is about 10 to 15%. We have the green is polymers and foils, which they usually use for this waste energy, is about 10 to 15%. And then there's a mixture of other glass, foil, and metals for the other components. In the US, we have a similar process where we have a disassembly, which will remove the frame, and that gives us the aluminum portion, the wire, gives us the copper we can recover. The junction box has some copper, plastic, and then some e-waste. And then we have to delaminate the glass from the silicon in the ethylene vinyl acetate material that's used for laminating. And there's some other metals in that component, so they use different processes for that. And then there might be some material that's hazardous, such as in some of them, if there's lead, cadmium, etc., and then there's landfill. Now, First Solar is a manufacturer of solar panels, and they also do recycling of their own panels, and they primarily deal with the cadmium telluride thin film technology. This shows the recycling steps, which are similar to the ones I just indicated, where they are crushing and, here we are. They are crushing and shredding to get the different components separated. And then here's the glass separation that they can then reuse some of this glass and materials. And then they also precipitate out the metals that are in the solar panels. And then they have a third party that can help them recover the tellurium and the cadmium products. And it's important that many of these recyclers, and in this case, because they're also a manufacturer, they can then put back those materials into their manufacturing process. For example, for the tellurium, it's been indicated that in about 2020, they will then start having enough of the recycled tellurium to use in making new panels so that the original feedstock will then decrease down to about 2040 when, depending on the different scenarios, they might either be able to have 10 to 50% of their tellurium come from recycled end-of-life panels, or in some cases they predict they will be able to fully rely on the tellurium from their end-of-life panels to get the tellurium for their new products. First Solar took a look at the life cycle benefits of recycling and indicated that even though there's a recycling cost because it requires energy and materials that can increase the life cycle environmental impact, but also then, as I had mentioned, the recycling produces some products, copper, glass, the cadmium and tellurium, that can either displace those primary sources and be reused, so that actually cuts down on the environmental impact of having to mine or obtain and transport the new materials. So they calculated that actually the credits are greater than the impacts, so there is a net benefit to the recycling, and that's why they've coupled their manufacturing with recycling. This again shows the different amounts of materials that can be recovered from the panels. Looking ahead to 2030, we see that these are rather large volumes. We get about 90 metric ton of material of silver, some of the other metals, that goes on to the aluminum, and then glass, of course, is the major component. And one thing to consider is some of these materials, of course, have different relative values. The silver, for example, is one of the most valuable parts of the solar panels, even though they're only using small concentrations. But that's about 47% of the value of the recycled materials. And there's kind of a trade-off in that there's talk of using less and less silver in the panels to avoid some costs, but that will then make it harder for the recyclers to make money essentially on recycling these panels because there'll be less silver for them to recover. So that is something that the recyclers, one of the concerns that Jennifer will talk about with recyclers, they need to be able to recover enough materials to make it worthwhile for doing the recycling. So conclusions on the recycling processes then are that we've seen that recycling and repurposing both can have great environmental and economic benefits. A study in 2016 by Arena indicated that there could be actually $15 billion in recoverable value by the year 2050. That's about $2 billion would be in the U.S. And that these recovered materials could make 2 billion new panels. And that this we see for Illinois and the U.S. and globally could really increase solar panel recycling and repurposing jobs and new industry. With that, I'll now turn it over to Jennifer, who's going to talk about the guidelines for solar panel disposal, then the status of solar panel recycling, and then the outlook for Illinois and next steps. Jennifer? I need to give her the microphone.
Okay, as Nancy mentioned, I'm going to talk about these guidelines for the next steps in Europe and the US. Right now, what's set up in Europe is through the European Union's waste of electrical and electronic equipment, or WE. And the key purpose for them is to contribute to sustainable production and consumption in the market for lots of different technologies. They added PV waste technology to their guidelines in 2012. And this holds the producer responsible for the product's end-of-life treatment. There's a difference in producers. It's not just the manufacturers, but it also includes distributors or sellers or resellers of these products, importers, and internet distance sellers as well. This program is run through a company or nonprofit called PV Cycle, and they are the world's first collective take-back and recycling program for PV modules. Through the system, they have a network that makes it easier for the end consumers to recycle the products. So as Nancy mentioned earlier, there's no dedicated national program in the US for recycling, and many of these PV modules unfortunately find their way into landfills. This end-of-life disposal of solar products in the US is generally governed by RCRA and other state policies that govern solid waste depending on the state that you're in. Testing is required to determine if these products are considered hazardous or non-hazardous, and as Nancy mentioned earlier, that is variable on the technology itself. This solar waste can basically include multiple types of heavy metals and may be classified as hazardous waste also. Given that we don't have federal regulations, there are a few states that are taking the lead on these efforts. The state of Washington, California, and New York are working on disposal regulations of their own. A few other states, such as Illinois, have required large-scale solar installations to have decommissioning plans in place. However, these plans do not include the disposal guidelines or of recycling the equipment itself. This is mostly to return the land to the original state. Some studies have shown that modules that were put into service in the 1980s are still performing at or near their original specifications, but again, it's crucial to have this cohesive national recycling regulation in place. So now I'm going to talk about those three states and what exactly they have going on, and those are some thoughts we can consider as we begin to build out a network and a plan for Illinois. In 2017, Washington State became the first state to pass a bill that requires manufacturers that sell solar within the state to have a plan in place for their equipment. These will be regional take-back locations that will be set up so it's easier for the end user to have access once they need a network for recycling. And this will be at no cost to the system owner. These program details are just now being determined on how this will work, but that program will take place in 2021. In 2015, California passed a bill that requires safe removal of old modules. These regulations designate end-of-life solar modules as universal waste. And this is similar to televisions and batteries. By these standards, universal waste cannot be trashed or landfilled, but this legislation does not address how these are to be recycled or disposed of. And currently, right now, New York State is in the process of creating a law that will work with manufacturers on collection, transportation, recycling, and disposing of modules. This plan will also include educational outreach funded by the manufacturers. The bill passed the Senate in June and is now waiting on the Assembly for approval before going to their state governor. So that's not for sure going to happen yet, but this is in the process. Next up, I'm going to talk about what the status is of recycling in the U.S. We kind of went over the guidelines in this prior section, but we'll talk about where we are in the U.S. next. So right now in the U.S., we have a few companies that are starting to recycle PV modules, and as Nancy mentioned earlier, they're usually companies that have recycling in place, such as e-waste or glass, and then they work with other vendors. So that's similar to what Europe has right now. The value of these materials is determined through the yield and purity of the output, as well as the cost of collecting and transporting the materials themselves. So as you can imagine, this would make current cost of recycling very high. So most of these companies, again, are designated for glass and metal and e-waste. And I just wanted to kind of go over a few companies that we have in the U.S. that are currently doing this. I have here just a couple different lines to describe what these companies are doing. Right now, Clean Lights, they're located throughout the country, but we have them in the Midwest as well. And they've been around since 1994, but they just started recycling in 2015. And as you can see, most of these recyclers have recently begun picking up e-waste or PV waste. They've been working in other types of technologies, but PV has recently been added to their processes. The only one we see here is First Solar. They've been around since 2005, and that's because they are a manufacturer of solar products. So as Nancy mentioned earlier, they thought this would be a good idea to add this into their process and have an end-of-life recovery. This line here kind of talks about how many metric tons have been recycled by all of these recyclers, and here's kind of some unique details on each of them. Recycle PV, they stemmed off of PV Cycle, which started in Europe, and they are new to the U.S. They just started up this year. They are doing take back of about $15 per panel, so that kind of gives you an idea of the cost involved with recycling this waste. So a little history. Solar's basically been around for consumers since the 1970s, when the US DOE created the investment tax credit for solar. But we really didn't see a rise in the technology out here and accessible for us to have on our roofs and whatnot in businesses until basically the 90s. And in the 90s, they had advancements through the DOE as well that made it easier for customers to access solar. But given that these didn't really increase till the 90s, we've not seen a need for recycling in this market. And in 2016, it was shown that the North American solar recycling market was valued at $11.2 million. So that's basically some of that stuff that's being decommissioned from the 90s. So as our numbers show, as Nancy showed earlier, they're continually growing, and we're going to see a large demand, specifically by 2020. So what is being done to prepare for this waste that we're about to see? The Solar Energy Industries Association, which Nancy mentioned earlier, they're developing a national solar recycling program that aggregates recyclers and manufacturers to make it easier for end consumers. This program chooses recycling partners through an evaluation process, so they have to become approved through SEIA. And as the industry continues to grow, more PV recyclers will hopefully begin to get established through this program. What we're seeing in the industry from PV recyclers, they really would like to see manufacturers clearly label their products so it's easier for consumers to understand how to access recycling. And then education for contractors, how to support the end-of-life PV once it's installed and decommissioned. And then lastly, they would like to see a single point of contact for customers to make it easier to access, possibly online or through an agency that might be able to handle that as a national effort. All right, next we're going to talk about the solar outlook in Illinois and next steps for recycling. So as many of you have heard, the Future Energy Jobs Act, or FEJA, passed in 2016. And that was passed to fix the funding for the Illinois Renewable Energy Law. This mandates 25% of ComEd and Ameren's power come from renewable energy sources. And through FEJA, it is estimated that this will require about almost 3,000 megawatts of new solar to be installed in Illinois by 2030. So that's quite a bit from where we're at right now. This plan also includes long-term funding for low-income solar installations, as well as job training for low-income returning citizens, and as well as the foster care alumni system. Helping place them into jobs that are in the industry. I also wanted to mention that the training has just begun this year, so we'll start to see that, as well as the IPA just announced that they'll be probably starting the low-income stuff as of 2019. So we'll start to see that increase in 2019. According to SEIA, there's over 300 solar companies in Illinois, and most of which are installers. You can see here, they mostly take place in Chicagoland region, but we have a lot down south as well. We do have some manufacturers, but I want to highlight when we hear the word manufacturers, they're not module manufacturers, they're mostly components. So they might manufacture the glass that goes onto the module, or the backing that holds the cells in place. So there's many different components, as Nancy had mentioned, that come into play when we think about what it takes to make one product. This map just kind of gives you an idea of where current installations are in the state. These little house-looking ones are on schools. And then this is mostly in populated areas of the state, is what we're finding. And if you think about that, that's where we're going to probably see the most distributed generation growth. So that's where you're getting your energy at the source will probably be right there on your roof. Community solar and utility scale solar will be projected to be installed more rural areas of the state, so you have more land to access bigger installations. And ICEA, the Illinois Solar Energy Association, is predicting that those larger scale installations will be installed west of Chicago, so it has quick access to the grid, and in southern and central Illinois as well. And then this kind of gives you an idea. I just wanted to point out some of the large-scale installations that we have right now throughout the state. This is what we have, so that's going to grow tremendously through FEJA. But I wanted to highlight the university's got the third largest solar farm here in the state, so that's pretty impressive. And then just to kind of process those numbers, we currently have 87 megawatts, as Nancy had mentioned earlier. Oops. That equates to approximately almost 350,000 panels that are installed right now. With FEJA's requirements, that's going to push us to 11 million new solar panels to be installed by 2030. And if we talk about the weight and how much waste we have with weight, panels usually range from about 35 to 50 pounds, and that's approximately, about 200,000 to 300,000 tons of installed modules in Illinois by 2030. So that's a lot of waste we need to kind of prepare for after FEJA starts to roll out. So some end-of-life options for solar panels in Illinois. So in order for a waste to be considered non-hazardous or hazardous in the state, it first must meet the definition of solid waste. And the Illinois EPA has 2 regulations that govern how this waste is to be classified. And then we also have, this just recently passed in June of 2018, the Agricultural Impact Mitigation Agreement that was signed into law. This agreement basically is an extension of existing law that pertained to commercial wind energy facilities. It's intended to ensure that the land, agricultural land, is returned to its original state when it's a commercial site and decommissioned. AMIA provisions include decommissioning plans, but keep in mind they don't include what to do with the equipment once it is decommissioned. Do those get recycled? Do those get repurposed? Do those get reused? There's a lot of material there that can be recovered and repurposed or even recycled. And then lastly, I just kind of want to highlight what we're doing here at ISTC. We're planning strategies to include investing in research and development and recycling technologies. We're also working with the Illinois EPA and Solar Energy Industries Association and the local state association, Illinois Solar Energy Association, to collaborate on outreach, examine policies and regulations, and to establish a network of PV recyclers in the state to prepare for this upcoming waste. We're also partnering with training organizations to help prepare a workforce in this new industry, this new renewable industry. And then we are also interested in developing a network to help repurpose old modules once they are decommissioned, if they don't need recycled. So lastly, I just wanted to let you know we have a little display out there if you're interested. It kind of has some interactive stuff with some videos, as well as some sites in the state that you can go to and see energy produced on the spot. And then also, if you'd like to visit our website, we have more information as well. But if you guys have any questions, Nancy and I are more than happy to answer them.
Oh, and the display that Jennifer mentioned is in our gallery, which is just down the hall to the left, if you want to look at the solar panel display. And we have some solar panels there you can see, etc.
Does anyone have questions?
Oh,
So thanks for the great presentation. I guess I'm curious about the planning for end of life and what kind of teeth there are to make sure that that happens. Because it's one thing to have a plan that costs hardly anything, but it's quite another thing. And I'm wondering, if a company goes out of business, how does the end of life plan actually get implemented?
So do you mean by, like, if the manufacturer goes out of business, similar to like how Washington State has it set up? So they pay, what right now the legislation in Washington State, the manufacturer pays into this upfront, so the funding is already there for the end consumer. So if the manufacturer themselves, the module manufacturer, goes out of business, that is set in place for 20 years, 30 years down the road. In Illinois, we don't have a plan set in place, and we're kind of working with other agencies, EPAs here today, and ICEA and the National Industry Association as well, to kind of figure out what works best for our state. It might not be similar to Washington. It might.
So then to follow up on that, so if the way to do it, if the way it's being done is to essentially pre-charge for the disposal, is there a concern that you limit the growth of the industry because you're building additional cost into it at the front end?
That is a big concern of the industry right now.
And that is why we're also in upcoming meetings and discussions, we'll have different associations there, but we're bringing installers and manufacturers and recyclers into our discussions to see what impact, how we can best set up a program here. So, thanks.
Any other questions?
Is there any way now to evaluate the relative recyclability of different manufacturers' panels?
I don't know if they've done that, but most of the panels, from what we've looked at on their websites, at least 90% of the materials can be recycled. I mean, it's really quite high. The problem right now is for them to set up to do the recycling. There's not the volume. Most of these are just damaged panels from manufacturing or in transit. There's just not the volume that they need to really make dealing with them economical right now. And so, but they're all saying, well, in 10 years or so, then it's going to be really economical. We just want to be sure they're set up now. But I think most of the panels, at least 90 to 95%, can be recycled.
Are you aware of any contract specs requiring end-of-life management of solar panels for those looking to issue RFPs for installation?
Could you repeat that again?
Are you aware of any contract specs requiring the end-of-life management for solar panels for those looking to issue RFPs for installation?
There aren't. The only specs that I know of in Illinois are basically about, decommissioning and the land, the AMIA amendment, to return the land back to. We would like to work with others to help set up contracts, but again, that really impacts the industry, as Lance was mentioning. So it really makes it hard if one contractor is placing a bid that's going to, include the end-of-life management to be competitive, cost competitive with someone that's placing a bid that's not including that in their options. So maybe Nancy can answer that.
Sure. Well, I think that's why we need to have a policy for the state, so that all the manufacturers and those having panels here, and it would make it easier for those putting out bids to know what requirements they could ask for.
Another statement here is the state of Minnesota requires take back for all solar panels installed at public locations, specifically Camp Ripley.
Great, that's good to know.
So one of the things that you were describing, honestly, I don't remember which one of you were talking about it, but the determination of whether or not the solar panels are hazardous waste. You were saying that that's done when, like, the panel manufacturer the way they've made the panel helps determine that. So is that a requirement that all solar panels that we might end up installing somewhere, we could ask them to tell us, is this hazardous waste? Or we could say, we want ones that are not considered hazardous waste? Is it always checked, or is it something we would have to ask them to do?
Do you guys know how to answer that question? Okay. Okay.
This is James Jennings. I'm with Illinois EPA. So state and federal law both require a determination once something becomes waste, what type of waste it is. And there are a number of ways that can be done, and it can be either through testing or generator knowledge. So to your point, if the solar panel manufacturers provide individual specs on each component of the panel at the time it's manufactured to the person using it, that person, once it is disposed of, could use that to constitute their own knowledge for whether it's hazardous or not. One potential issue that you can encounter, just given the lifespan of some of these panels, is that something that may be hazardous waste today could possibly not be in 30 years, depending on regulatory changes or vice versa. So it'd be difficult to make that strict hazardous, non-hazardous determination that would withstand the test of time, but almost a ingredient list, for lack of a better way to put it, could be helpful in rendering those determinations a lot more efficient.
Is the industry making the panels so they're more easily to be recycled? Are they working on that, or maybe I missed something?
I think it's actually the opposite, because they're trying to make them last longer right now. So again, as Nancy's earlier slides mentioned, that could change in time. You know, how this recycling process may work.
So what are the major hurdles in recycling of these solar panels in US right now? Is it the amount of material available, or is it the policy, or is it economics, or combination of all three?
I think it's the amount of material available. We've heard there's just not enough volume to keep them running every day with recycling solar panels. And then also, well, I forgot which other, so the economics just aren't there for them yet. But I think we'll see more companies getting into the recycling in the next 5 to 10 years as they see the value of recovering all these materials.
To follow up on that question, are there companies currently that could adapt their business model to take on PV waste? Is that something that could happen fairly quickly, or is that an industry in itself that would take 5 to 10 years to mature?
We're currently talking to some e-waste processing companies right now, because we see them as the most likely people who could take on this volume. And from what they've told us, right, as soon as there's more volume, they can look at it more closely. But right, they're set to handle glass waste and metals already. So I think there are companies who could pretty quickly switch to take this on once there's the volume and they see the economics.
So won't it be better for glass recycling companies, because almost 80% of it is glass? So if it goes to glass recycling companies, they can take the glass waste and then remaining can go to e-waste recycling companies?
Yes, certainly glass recyclers seem like they would be a logical companies to want to step into this more. So I think it's a combination. I don't know. You know, we just happen to be talking to an e-waste company right now, but glass recyclers too could step into this, like they seem like they've had over in Europe.
So how big of a challenge do you think it is to try and guess what solar panels are going to be made out of 20 years from now and set up a recycling system today that can deal with the fact that they might be made out of completely different materials 5 years, 10 years, 20 years down the road. Is it even reasonable to set up something like that, knowing that it's likely that it'll change?
Well, I think they can set up something now because at least in the next 10 years or so, we know what they've been made of. So all these panels right now that we've installed them 10 years past and 10 years future, they can handle. Then I guess they will have to see. That's why I mentioned that it's going to be important to watch the technology, and they may have to change some processes. But at least for the next 10 to 20 years, they'll have a lot of volume with what they know currently.
From online, are there any health and safety considerations for the workers performing the recycling? Just curious as the education level that would be needed for these jobs, or is it similar to e-waste?
I would think it's similar to e-waste, but that's one thing we're looking at, and we're going to be talking to, for example, some of the community colleges who already have some training in some of those fields. If there's some new requirements, we're also talking to the solar installers to see the skills there, because, but I think right from the e-waste recycling, a lot of the same metals exposure, et cetera, would be there.
And just to add to that, we're going to be in communication with some of the existing solar recyclers to see what kind of skill sets are needed as this job industry increases.
As far as I've heard some, I think they're working on technologies for like roofing materials to be made out for PV for consumer roofs. Where's that at today, or how far is that expanded?
So you're thinking of the building integrated technology. Yeah, it's more advanced, but it's, I don't know, in my opinion, it's still not worthwhile. I think the traditional modules are the best bet.
Do you know if anyone looked at reuse of the PV cells just, and how does it compare in terms of economics and greenhouse gases if you're taking the PV cells out of these solar panels and reusing it for some other applications?
No, we don't know that, BK, but that's a research area you can look at.
Thank you very much for attending today's seminar. Just a reminder that the next one will be John Steyer on September 20th. Thank you very much.